So here we've got to remember that in a dilution is the ratio of serum to total solution. So if I have a 2 and 7 dilution, the 2 represents the serum, and the 7 is representing the total solution. So if I want a ratio of serum to water, or serum to NS, if I want to put it that way, how many parts of serum are there? Still 2. How many parts of water are there? 5. Good. There's 7 total parts, and 2 parts are serum. 7 minus 2 makes 5. So it's 2 to 5 is that ratio. And we had kind of mentioned a little bit last week some things like this. If I wish to create a 3 in 10 dilution, how much water, how much NS should you add to 21 milligrams of serum? So looking at this, we have the 3 in 10 dilution. And again, the 3 represents the serum, and the 10 represents total solution. Well, here we are given the amount of serum. We're not looking for the amount of total solution. So we have 2 options. We could use this ratio and make a proportion, cross multiply and divide, but we'd have to subtract later. So I'm going to do this. I'm going to create the ratio of serum to water, to NS. So that's going to be 3 to 7 is that ratio. So now the amount of water is what I'm looking for. That's this number. And I have the 21 milligrams of serum. So I can now cross multiply and divide. 7 times 21 divided by 3 is going to give us 49 milligrams. So let's say I'm asked a slightly different question. To create 48 milligrams of a 1 in 7 dilution. Actually, not 1 in 7, sorry. We'll go 1 in 6 to make it easier on us. So to create 48 milligrams of a 1 in 6 dilution, how much NS should be used? So again, we've got 1 in 6. 1 represents serum, and the 6 represents total solution. We're given the 48. Does that represent either the serum or the total solution? It does. Well, yeah, it represents the total solution. You're absolutely correct. 48 milligrams does represent total solution. Are we looking for the amount of serum? No. Again, we can cross multiply and divide to find the amount of serum and subtract to get the amount of water. But I'm going to go ahead and I'm going to make the ratio. I know I need the total solution, so I'm going to make the ratio of NS to total solution, to total. So the total is still going to be 6. What's my water? How many parts of water or NS is there going to be? 5. Yeah, 6 minus 1 makes 5. So now I know I have 48 milligrams of total solution, and I can cross multiply and divide to get what, 40, right? Milligrams of water. Any questions? Or I might have milliliters, I can use whichever there. 120 milligrams of NS are used to create a one in 4 dilution. How much total solution is created? I'll give you guys a second in your notes to see if you can figure that one out on your own. So this is an example where we can't use the original dilution. Both of these two examples I've done earlier, I could have used the original dilution and I just would have found a number and I would have had to subtracted it out. Same with this one up here. I could have just used the dilution to find the amount of total solution and subtract the serum to get how much water was there. But here, the only thing I am given is the amount of water. I cannot use that in this dilution here because nothing in this ratio represents the amount of water. So this one has to be adjusted to use the water. Am I comparing the water to the total solution or to the serum? I'm looking for how much total solution. So I'm going to be comparing water to total solution. I don't know why I'm forgetting to use NS today instead of just water. So anyway, what's that ratio going to be? 3 to 4. Good. We still have 4 parts total. 4 minus 1 leaves us with 3 parts of water. So then we can put in the 120 on top. Cross multiply. That was milligrams, by the way. Cross multiply and divide is going to give us 160 milligrams of total solution. Well, let's say that we have 200 milliliters of water combined with 40 milliliters of syrup. Find the dilution created. So for dilution, looking for the ratio of serum to total solution. Up here we don't have those numbers. We have the serum. I said 40 and I wrote down 4, didn't I? It should be 40 milliliters of serum. We have the serum, but we don't have the total solution. There's 2 ways we can go about this. The simplest way would be just this. We'll put in our 40 milliliters for serum. What are we going to put in for the total solution? Is it going to be 200 milliliters plus the 40 milliliters, right? We have to add the water, the NS, to the serum to get the amount of total solution. So this is going to make this 40 over 240. And then we reduce it just like we would any other fraction, except we don't make any improper fractions. Both of those can be divided by 40. Give me a 1 in 6 dilution. So that is a 1 in 6 dilution. And we're going to look here in a little bit as to why that is important. One of the applications we use dilutions for is for blood testing, urine testing, and so on. For example, let's say we have a meter that's only capable of going up to 800 milligrams per deciliter for testing blood glucose, for blood sugar. So let's say we take a sample of blood from a patient, we test it, and the meter gives us an error. It says it exceeds the meter. So what we can do is we can dilute that blood and test it and then work backwards. So let's assume we have that patient that their test has exceeded the meter. So we are going to perform a 1 in 4 dilution and retest. So the first thing I want to ask is, how much sterile water to add to 80 microliters of blood? But we're going to perform a 1 in 4 dilution. To perform a 1 in 4 dilution, remember the 1 is the serum, the 4 is total. We know the amount of serum. We are looking for the amount of water, of saline. So we're going to need to adjust this to the ratio of serum to NS, to water. And that ratio is going to be 1 to 3. 4 minus 1 gives us 3. Total minus serum gives us 3 parts of water. So now that we have that as a 1 in 3 dilution, we're going to have 80 microliters of blood. That is our serum in this case, or our concentrate. And we're going to cross multiply and divide. 3 times 80 divided by 1. We require 240 microliters of sterile water to be mixed in with it. Now let's say the test of our diluted sample gives 258 milligrams per deciliter as the reading. So the second thing we have to find here is find the undiluted reading. Well, this goes off of our dilution ratio again. Are we using the 1 to 3? Say no. We use the 1 to 4, our dilution ratio. The serum to total. Now the 258 is the diluted number. It is the smaller of the two numbers. The undiluted number should be larger, right? So that's telling us that the 258 has to go with the smaller number. So that's going to go with the 1. And then we will cross multiply and divide, which will give us 1,032 milligrams per deciliter. Does that make sense? Okay. Let's look at another example that we're going to approach just a little bit differently. So once again, we exceed the meter. We exceed the meter capability or exceed the meter range, however you want to word it. So we are going to dilute 20 milliliters of urine with 80 milliliters of sterile water. Test gives a result of 198 milligrams per deciliter. So find the result, the true result. So our first step here, we're given the amount of sterile water, of NS, that's going to be used here. And we're given the amount of the concentrate of the urine. So our first step we're going to have to do here is find the dilution. Dilution, remember, is serum, or in this case, concentrate, to total solution. So in this case, how much serum or how much concentrate was used? 20 milliliters of urine. That would be our concentrate. So 20 milliliters. How much is my total solution? Got 20 plus 80. Which, yes, that does give us 100. So 20 over 100. Notice I took out the milliliters because they would divide out. They would cancel out. And I can reduce both of those by what? 20. Yeah, I can reduce by 10 and then by 2. But we'll go by 20 to give us 1 to 5. So that is a 1 in 5 dilution. Now to find the true reading, we use the 1 in 5 dilution. We had the test result of 198 milligrams per deciliter. Where's that going to go? On top. Because the true result should be bigger than that. So we cross multiply and divide. 5 times 198 divided by 1 is 990 milligrams per deciliter, the true reading. What do you guys think? Not horrible? Okay. I'm going to give you guys an example. So again, we're going to assume we exceeded the meter, so I'm not going to state that part. But you're going to dilute 80 milligrams of blood with 120 milligrams of NS. Find the true reading if the diluted reading is let's see here, 360 milligrams per deciliter. I'll pause and give you guys a minute to. So our first step to try this would be to find the dilution. And of course, the dilution is serum to total volume. How much is our serum here? That's the blood, that's the concentrate, 80 milligrams. What's our total? 200, perfect. 80 milligrams plus the 120 milligrams of water. So we have 80 over 200. If I reduce that, what can both of those be divided by? 40. 2 to 3. Oops, 2 to 5, sorry. A 2 to 5. So it's a 2 in 5 dilution. What do I do next? Find the true readings. We're going to use the 2 in 5 dilution. What goes on the other side? 360 goes top. So 360 milligrams per deciliter. We cross multiply and divide. 360 times 5 divided by 2 is what? 900? How many of you got 900 milligrams per deciliter there? How many of you are just short of time? Okay. So let's do one more example. Again, we assume we're going to exceed the meter. Let's say to use a 1 in 5 dilution, with 60 milliliters of blood. How much NS should be used? And find the true reading if the diluted reading is 184 milligrams per deciliter. Pause for a minute and let you guys see how far you can get on that. So for this one, the first thing you got to figure out is how much water using that 1 in 5 dilution. So the 1 represents the serum and the 5 represents the total. So we're going to create the ratio of serum to water. What would that ratio be? 1 to 4. So we can use that to find how much water to use. We have 60 milliliters of blood, which is our serum or our concentrate. Cross multiply and divide, we get 240 milliliters of sterile water to be used to dilute that sample. So once we have it diluted, we have a 1 in 5 dilution. We had a diluted result of 184. That's going to be a small number. Cross multiply and divide. 184 times 5 divided by 1 is, what's that? 920, exactly. 920 milligrams per deciliter. Now, there's one thing to be a little bit careful of here. Most of your meters have an error factor into them, right? So let's say your meter is plus or minus 5 milligrams per deciliter. We diluted that sample. So on the diluted sample, that error is still plus or minus 5. But in our result, that error is going to be magnified. And I'm going to demonstrate how that works here. If this result is the plus or minus 5, that means it could have been as low as 179 or as high as 189. So if I were to deal with my dilution there, cross multiplying and dividing here, 5 times 179 divided by 1, that is telling us that that could have been as low as 895, or cross multiplying and dividing here could have been as high as 945. The difference between those two numbers is 50 milligrams per deciliter. The distance of each of those from the 920 that we calculated is now plus or minus 25 milligrams per deciliter. I can take the 920 and subtract either one of those to get a difference of 25. Or I could just cut the 50 in half to get a plus or minus 25. So what has happened here is our error in our meter goes through the same dilution process. If it was a plus or minus 5 milligrams per deciliter before, 5 times 5 divided by 1, it is now plus or minus 25 milligrams per deciliter. So something to be aware of. So I used some large dilutions here just to make the math more interesting. In practice, you would want to dilute it as little as possible to get it underneath the limits of the meter. Now you want to dilute it enough so that you don't have to go back and draw more blood from the patient too. But let's look at a sample that's exceeded the meter. And let's say you want to dilute 40 milliliters of blood. And you want to reduce that error as much as possible. So I'm only going to dilute it with 10 milliliters of sterile water. Find my percent gain. I'll explain that in a little bit. But let's say that the diluted reading is, let's go 640 milligrams per deciliter. Find the true reading. So let's go through with that diluted reading and true reading. Our dilution is going to be our serum or concentrate over total. The serum here was 40 milliliters. The total was 40 milliliters plus 10 milliliters. So 40 over 50, or 4 out of 5. This is a 4 and 5 dilution. So now if I use that 4 and 5 dilution to adjust my sample, I put my diluted reading, still goes with the smaller number, 640 milligrams per deciliter. And I can cross multiply and divide. 5 times 640 divided by 4 should be 800 on the nose, right? So for a standard blood glucose reader, that would have been right at the limit. But I also asked, what is the percent gain here? Well, the percent gain here is the change from the diluted reading to the actual reading. So that change is 800 minus 640 over the 640. So 160 over 640 reduced to a decimal of 0.25. The reason I'm put it as a decimal rather than just reducing the fraction is this is going to become a percent. So to make that into a percent, we just remember to move the decimal point 25%. So that's a 25% gain. Another way you can look at that, finding the gain, is just the ratio of sterile water to serum. Because we put 10 milliliters of sterile water in 40 milliliters of blood. If we did 10 over 40 and reduced it down, we would still get 25%. So there's one of the cases we had mentioned last week that we almost never use serum over, or saline over serum. It's always serum over saline. Here's one example where we would use it in the other direction. So anyway, let's take a look at what if we want to reduce the concentration of a solution. So we wish to reduce a 40% solution to, oh, let's just make it easy, go 10%, just by diluting it with sterile water. So our question, how much NS is needed to mix with 60 milliliters of the 40% solution? So what we're going to look at here is we have 60 milliliters of solution, right? It is a 40% solution. To find the amount of medication, the amount of serum, or whatever our active ingredient is, remember, it is always the concentration, which is 0.4, times the volume or the mass, whatever is given. So 0.4 times 60 milliliters gives us 24 milliliters of medication. We want to reduce this now to 10%. We're still going to have, because we put this 60 milliliters of 40% into this, we're still going to have 24 milliliters of active ingredient. That cannot change. What's changing is our concentration is now 10%. We need to know this number here, big X. That's the amount of 10% solution that I'm going to have. So, to solve for X, I'm going to divide by 0.1. X equals 240 milliliters. Does that make sense so far? I just solved this equation backwards. That's my concentration equation, or formula. So I need to have, that's my total volume after it's diluted. How much did I start with? I had started with 60 milliliters. So you get from 60 milliliters to 240 milliliters. 240 minus 60, that means I added 180 milliliters of neutral solution, of normal saline. So the dilution created here was my 60 milliliters of my concentrate. I'm using the term concentrate instead of serum here because it's not pure serum. It was a 40% solution before, but it's the higher concentration. Over, do I use the 180 or the 240? I use the total amount, which is the 240. So the milliliters cancel out. I have 60 over 240, which is going to reduce to a 1 in 4 dilution. So now that I've figured that out, anytime I want to reduce that 40% solution to 10%, I know I can do a 1 in 4 dilution to do it. Well, let's say that we have 120 milliliters of 72% solution. If we add 300 milliliters of NS, find the new percent, find the new concentration. So what we need to do here is we need to dilute this down. We had how much active ingredient before? Well, 72% is 0.72 times 120 milliliters. .72 times 120 is 86.4 milliliters of serum of our active ingredient. So our dilution here, not a dilution, our new percent here is going to be 86.4 milliliters over how much total volume do we have? How much total volume do we have here now? We had 120, we added 300 milliliters, right? It's now 420 milliliters. So we can solve this concentration formula now for this. X is now the concentration, or the percent. So what we would do is we would divide by 420. .4 divided by 420 is 0.205714285714. 0.2057. And of course, as a percent, that's 20.57%. So adding that 300 milliliters of water to the 120 milliliters of solution diluted it to 20.57%. We could find the dilution created here because we had the 120 milliliters of a concentrate over, it was 300 plus 120, right? Or 120 plus 300, however you want to write it. So that is 120, a drop of milliliters, over 420. Both of those can be divided by 60, give us a 2 and 7 dilution. Let's say we take .30 milliliters of 48% solution. Through a two and 5 dilution. Find the new concentration, the new percent. So in a 2 and 5 dilution, the 2 represents the concentrated serum. That's going to be our 48%, right? The 5 is the total volume. Two to 5, I'm going to rewrite that as my ratio of my concentrate, my 48% to the water. That would be 2 to 3, right? So I'm going to find how much water was added to the 30 milliliters. Cross multiply and divide. 2 times 30 divide, or 3 times 30 divided by 2 is 45 milliliters of NS. That was what was added. To find our new concentration, well, we had 0.48 times 30, which gave us 14.4 milliliters of active ingredient in that solution. And now we have still have 14.4 milliliters, but we now have a total volume of how much? 30 plus 45 makes 75 milliliters total volume. So we're looking for our percent here. So I divide by 75. 14.4 divided by 75 is 0.192, which is a 19.2% solution. Now, in each of these examples I did it out the long way. Now I want to go back and I want to look specifically at the before and after for each. So for this first one, I went from 40% to 10%. So I'm going to put the new percent over the old percent. 10% over 40%. That is a 1 to 4 ratio. If I look at my dilution for that problem, what did I come up with the dilution for that problem? It's a 1 to 4 dilution. Here I started at 72%. Put 72% on bottom. I finished at 20.57. If I reduce that, it's going to get kind of ugly. Did I forget my dilution for that one? Yes, I did. A 2 and 7 dilution. If I looked at my dilution of 2 and 7, rather than reducing the 20.57, let's just look at this. If this is true, I should be able to cross multiply and get the same product in both directions, right? 2 times 72 should be the same as 7 times 20.57. 2 times 72 is 144. 7 times 20.57. Now we rounded that, so it's actually like 143.9 something. But it is 144. So you can see the ratio of my percents, the after over the before, the new percent over the old percent, is the same as our dilution in each problem. Let's look at our last one here and make sense. Make sure. This went from 48 to 19.2. So 19.2% is my new percent. 48% was my old. And we found that this is a 2 and 5 dilution. Does that hold true? Well, 48 times 2 is 96. 19.2 times 5 is 96. So yes, again, the ratio of the percents is equal to the dilution. It's a time for a break, so when we come back from break, we'll pick up right there. So let's take 10 minutes. We'll come back at 11:30.